The night has settled, warm and heavy like a blanket drawn across the sky. Your breath slows. Around you the noise of the day fades, and the world becomes quiet tripe for listening. And in that quiet, you find a doorway. It's not a door you walk through in the ordinary way. It's a door inside your mind, a turning inward towards smaller things, toward particles and patterns and whispers too soft for daylight. This is the beginning of something new, not made of wires or code, but of probability and wonder. You start with something you know, the bit. In the world of classical computing, bits are like tiny switches. They're either on or off, 1 or 0, black or white, yes or no. Every website, every email, every sound from a speaker, all of it is built from these crisp little decisions. But tonight, you walk beyond that. You walk into the world of the qubit. A qubit is like a bit, but softer. It does not stand stiffly, in a state of 1 or 0. Instead, it drifts. It leans into 1, bends towards 0, floats in between. It holds both states at once, but never in conflict. Like a coin spinning on the edge of a table knot, yet heads, not yet tails, but both. Somehow, this is called superposition. You lie still. Imagine it now, a glowing sphere of potential, not flat like a switch, but round, whole, full of depth. Inside this sphere, the qubit lives moving, shifting, listening to the quiet rules of the quantum world. You don't have to force your mind to understand it. Just let the image sit there, soft and round. It's not either or, but both and. Not here or there, but here and there. Superposition isn't chaos. It's grace. It's the pause between possibilities, like the breath before a musician touches. The first note, your body relaxes as your mind begins to feel. This rhythm to hold a qubit is to hold uncertainty, and yet it feels oddly peaceful. There's no pressure to choose yet, no hurry to decide. The qubit waits until you ask it something, until you measure it. Only then, it reveals one truth, falling into 0 or 1 like a petal landing on the water's surface. But before the question is asked, it simply is. It holds not just data, but potential. In your chest, you feel a quiet blooming. You've spent a lifetime in a world that demands decisions. But here, in this place of quantum thinking, you are allowed to not know. You are allowed to rest in the space between. This is not how classical computers think. They tick forward, one calculation at a time, like soldiers marching in step. A classical computer moves in neat rows, solving problems by checking each option one, then the next, then the next. But a quantum computer? It breathes. It opens like a flower at dawn, touching many paths at once. Superposition gives it this strange power. A single qubit can explore multiple answers simultaneously. And when you bring many qubits together, something extraordinary happens. Their possibilities don't just add, they multiply. 2 qubits can hold 4 states, 3 can hold 8, 10 can hold over 1,000. This is the beauty of quantum scaling, an exponential blooming of potential. You imagine them now, not as numbers, but as flickers of light in a deep ocean. Each qubit a glowing fish, swimming through all possible outcomes at once. The sea of thought becomes thick with potential. In this space, problems that stump classical computers can be answered in a breath, not by rushing, but by drifting through. All the options at once, you find your mind wandering. You wonder what it would feel like to live like that, to hold many truths, many feelings, many futures. You wonder if we already do, because in some small way, your own thoughts already behave like qubits. You've had days where you feel too. Things at once, joy and sorrow, certainty and doubt. You've made decisions with many possible outcomes branching inside your chest. You felt potential blooming and fading without words, and so perhaps you understand qubits more than you think. They are not foreign. They are not machines. They are merest tiny reflections of how possibility lives in all of us. You close your eyes and imagine a room full of qubits, not wires and glass, but shimmering points of maybe. A symphony of maybes. And though it feels abstract, something inside you feels comforted. There is more softness and uncertainty than you expected. There Is peace in the possible? In time, we'll ask these qubits to solve great puzzles. We'll build languages they can understand. We'll stack them into structures, fragile and beautiful, so that they can help us map out the unknown. But for now, you are simply here at the edge of the ordinary, listening to the whispering world of quantum thought. Each qubit hums in quiet probability, and you are no longer afraid of not knowing, because now you feel it. That uncertainty is not the enemy of knowledge. It is the space knowledge grows in. It is the fertile ground where intelligence blooms. You linger a little longer with this thought, as if standing on a soft hill overlooking a valley of shimmering maybe. But even here, something deeper calls. You've felt how one qubit can hold many truths. But what happens when two of them begin to feel each other? When two particles, though far apart, begin to move in quiet harmony? You feel a thread pulling gently from the edge of your awareness. Thread that stretches without breaking. And so you turn now toward a stranger mystery, where distance no longer means separation, and information dances between the stars. You drift deeper now, your breath slowing with the rhythm of thought. The world around you grows quieter still, less a room. It's more a dream, somewhere in the folds of this quiet space. Another quantum secret reveals itself. Not loud, not sudden, but patient. Like a thread, gently tugged. This thread is entanglement, and like all the best things in the universe, begins quietly. Imagine this. Two particles are born together. Perhaps they emerged from a spark of light, or the breaking of a single atom siblings. In the vastness, and from the moment they begin, they are connected. Not by wires, not by matter, but by a deeper rule. A rule that says what happens to one will instantly affect the other, no matter the distance between them. You lie still, and picture it. Two tiny specks. One drifts left, one drifts right. They grow further apart, miles, then continents, then light years. But still, they remain connected. It's not a physical string, it's a thread on a spool. Something quieter than that, invisible agreement. Written into their being, when one spins up, the other spins down. When one turns, the other responds, instantly like partners in a dance. Separated by oceans, but still in step. Einstein once called it spooky action at a distance. And in some ways, still feels spooky. But perhaps spooky is just another word for beautiful when we don't yet understand. Entanglement doesn't just break our idea of space, it transcends it. Because space is how we measure distance. But entanglement doesn't care about distance. Two entangled particles, there is no between. There is only together, and that idea of togetherness, without. Proximity settles into your thoughts, like warmth into your chest. It feels familiar. Somehow, you think of people you love who are far away. How sometimes you feel them think of you. How a song or a scent can bring them back into your heart instantly. As if no time has passed, and maybe, just maybe, entanglement is not only a property of particles, but of connection itself in the world of quantum computing. A strange link becomes powerful when qubits are entangled. They don't act alone. They share their state. They co-create answers. They multiply knowledge not by working faster, but by thinking together. And suddenly, computation becomes not a solo performance, but a symphony. This is how quantum computers leap forward, not by pushing harder, but by entangling more. Not by isolating logic, but by intertwining it. Each qubit doesn't just know itself, it knows something about its partner. And together, they form patterns deeper than either could hold alone. You think of this now, as your mind begins to quiet even more. Two particles, tied by an invisible thread. Distance between them, irrelevant. In one reflected in the other, perfect coordination. No signal, no sound, just understanding. And maybe this is what intelligence is becoming. Not just speed or memory, but the ability to feel across space. To think in patterns bigger than one's own mind. Maybe quantum computers, when they finally learn to think fully, won't think like us. Maybe they'll think more like the universe, connected, curious, and always listening. You lie here now, not solving anything, not rushing, just being with this thought, that perhaps everything is more connected than it seems, that particles are not alone, that we are not alone, that even in the smallest fragments of matter, there is a thread that ties us quietly together. You imagine the cosmos not as empty, but as woven, stitched with invisible cords of resonance. You feel your place in that web, not separate, but part of the grand harmony. And then, as the thread of entanglement pulls softly at your attention, you notice something else, something about choices. Because in quantum entanglement, when you measure one particle, you don't just learn something, you define something. And in that act of defining, you change the whole pair. You choose a reality for both, with a single observation. What does it mean then to look? What does it mean to measure? This quiet question, like the soft chime of a bell, begins to echo through your sleepy mind. You turn now toward it, gently. Toward the next mystery. Why does looking change the world? And how does something become real only when it's observed? Qubits await your gaze, suspended in all their possible truths. You drift closer to the moment they choose to become one. You float now in stillness, the thread of entanglement fading into the background. Like a lullaby that's been gently sung and gently set aside, ahead of you lies something softer still, a garden unlike any you've known, not made of petals or branches, but of paths, infinite paths, and all of them walked. It's the quantum garden of possibilities. It is not bound by the straight line of time or limited by the single track of classical logic. Here, everything that can happen does, quietly, patiently, and in parallel in classical computing. Solving a problem is like walking a maze. Each turn is explored one by one, each corridor tried and tested. Eventually, the exit is found, but the journey is linear. The computer tries, fails, turns back, and begins again. But in this garden, the maze is not walked, it is bloomed. Quantum parallelism allows a computer not to take one path, but to take all paths simultaneously. Each route, each twist, each possibility is walked in the same breath. You close your eyes and imagine it. Tree at midnight, silvered by starlight. Each branch splits into 2, then 4, then 1,000, and along each twig walks a shadow, exploring what could be. You are not just here. You are there too, and there. And there again, in this place, choice becomes art, not by eliminating options, but by letting them unfold. This is the power of quantum computing at its quietest, not speed in the classical sense, but presence. In many places, it does not need to test each key to unlock a door. It holds all keys at once. It feels which one fits. Your breath slows. The thought is strange, but not frightening. There's a certain comfort in knowing that you don't have to force the right answer, that sometimes, by simply being in all places, the answer reveals itself. It's how nature often solves her puzzles, the way water finds the lowest point, or how roots grow toward moisture without sight. No central plan, just quiet parallel wisdom. Quantum computers echo this same calm intelligence. They do not race ahead. They spread out like mist across a field, like scent on the wind, and within this spreading, problems begin to dissolve. You may wonder how. Do these systems not collapse under the weight of possibility? The truth is, they do. But only after they've finished listening. When a quantum computer begins its work, it prepares its qubits. They stretch into superposition, tangle into silent choreography, and spread across the garden of solutions. But when you ask for an answer, when you measure, the whole garden folds into a single bloom. This final bloom is the output, the answer the computer gives. But the magic lies not in the bloom itself. It lies in how gently, how deeply, the computer searched all the others before arriving. And though we only ever see the one path, the one petal that opened, we know it was chosen from a field of 1,000,000,000,000 flowers. That thought settles over. You now, like morning dew. You realize your own life is a kind of garden too. You may walk one path, But behind you lie 1,000 others' choices not made, roads not taken, and yet they shaped you too, not in outcome, but in possibility. Just as a quantum computer is shaped not only by the answer it gives, but by the quiet unfolding of every other option it considered. This is the lesson of the quantum garden, that presence is more powerful than pursuit. That understanding can come from stillness as much as motion, and as your body begins to soften into sleep, your mind remains light, open. Like petals at dusk, you are no longer afraid of the unknown, because you've seen now that knowledge is not a single point. It is a field, blooming in all directions, and somewhere in that field the answer you need is always growing, always just about to flower. But before it does, something else must happen, a gentle collapse, a quiet choosing, a single step into one of the paths. Where all others fall softly away, this next step is not something the garden resists. It is something it welcomes so too. Your journey continues toward the moment where the many become one, where possibility becomes reality, and where, with a single gaze, the world decides to take form. You turn toward that moment now, toward the act of measurement, and with it, deeper question, what does it mean to look, and in looking to change what you see? You stand now at the edge of the garden behind you. The air still shimmers with untaken paths, soft and endless. Ahead, the mist begins to thin, and somewhere in the quiet distance, a thought begins to take shape. What happens when we choose to? No. What happens when we ask the universe a question it cannot avoid? In quantum mechanics, this moment is called measurement, but it is more than a measurement. It is a moment of transformation. Imagine this. You reach into fog with an open hand. The air is thick with possibility, full of what dash could dash be. But the instant you touch it, the fog sent this. A single droplet forms on your finger. One truth emerges. The rest vanish. Like dreams upon waking. This is what it means to measure in the quantum world. Before you look, particle floats in superposition many places, many states. But the moment you observe, the wave of possibility collapses into a point. It becomes one thing, a value, a state, a known. The quantum world resists this moment, not because it is unkind, but because it lives in openness. To measure is to ask a question, and questions carry consequences. You breathe gently now, sensing this truth settle over. Your thoughts like snowfall. Every act of knowing is also an act of unknowing something else. When you measure a qubit and find it in the one state, you don't just learn what it is, you lose what it could have been. You discard the zero it might have held. You abandon the dance of maybe. In this way, knowledge becomes not just power, but responsibility. To look is to alter. To define is to confine. And in choosing one reality, you gently lay all others to rest. The world of quantum computing understands this deeply. When a quantum computer begins its work, it stretches into possibility. It holds thousands, even millions, of parallel truths, but it can't show you all of them. It must choose. And so, the final step. The measurement is a letting go, a graceful ending, a soft bow after the dance. You picture it now, a hall of dancers. Each one a possible answer. They move in perfect silence. It's undisturbed, but the moment you step forward and raise your hand, one dancer approaches, the music fades, the others vanish, and only one remains to bow before you. This is the answer the quantum computer gives, not because it was always the right one, but because your asking made it so. Your heart beats slower now. You feel the weight and the beauty of this, that sometimes the universe doesn't decide until we ask. And when we do, it answers not with a cold certainty, but with a kind finality. Perhaps your own thoughts work this way too. How many times have you hovered on the edge of a decision, lived inside the mist of maybe, and when you finally chose, did you feel the other paths? fade not in grief, but in gratitude because they gave you something. They gave you the shape of the choice. The quantum world echoes this rhythm. Every measured particle holds the imprint of the others it might have been. And so, even in collapse, there is remembrance. You shift gently beneath your blanket now, feeling your own mind drift closer to that quiet collapse. Your thoughts are softening. It's like waves settling onto shore. You no longer need to explore. You are ready to observe. And yet, even here, the mystery continues. Because if looking changes reality, then what is reality when we're not looking? This is the paradox that lives at the heart of quantum theory. The particle isn't. It's waiting for you in a hidden state. It becomes only when you see it, and so you wonder, what kind of world lives between the moments we pay attention? It exists. In the spaces our minds don't reach. Is the universe quietly pulsing in probability, waiting for our awareness to unfold it? You do not need to answer this. You only need to rest in the question. For even the most powerful quantum computers are still learning to live in this question, to sense the delicate balance between potential and reality, between the seen and the unseen, and just as their qubits shimmer into truth upon observation, so too your own awareness brings shape to your inner world. You observe your breath now, the rise and fall. You do not force it. You only watch, and in watching, you allow it to become fully itself. This is the gentle power of presence, not to change, but to allow change, not to command, but to invite. And in that invitation, truth arrives. The dance of measurement is not an ending. It is a pivot, a movement from maybe to now, and still beneath the certainty of what has become another mystery waits. What if your logic could mirror this softness? What if your thoughts didn't rush toward answers, but flowed like rivers between true and false? What if thinking didn't end in a conclusion, but rested in the space where both might live? You begin to drift now toward that thought award. A new kind of logic, logic without hard edges, a logic that thinks in curves and clouds, a quantum logic, where even contradiction feels like comfort. The night deepens, and you drift with it. You've left behind the binary world, the black and white. Certainty of bits, the sharp outlines of yes and no. And now, something softer welcomes you. This is a place where thoughts don't sit still, where truths don't lock into place, where logic flows like water and answers are not carved from stone, but gathered from the mist. This is quantum logic. You don't need to understand it with sharp edges. You only need to feel how it differs from the logic you've known in classical logic. Everything is firm. A proposition is either true or false. A light is on or it is off. A path is taken or not. But in the quantum world, logic opens its hands. A quantum beta qubit can be both, so the rules it follows must be flexible enough to hold this ambiguity. Here, something can be true and false, held in soft contradiction until the moment you choose to look. And this contradiction isn't wrong, it's part of the truth. You let that idea rest beside you now. Think of a rainbow, not just red, not just blue, but all colors together, blending. That's what quantum logic feels like, not either or, but both and sometimes neither, and sometimes more. You no longer walk a narrow road. You float down a branching stream in quantum logic. Propositions are no longer fixed points. They are states. States that evolve, interact, and interfere with each other, like ripples on a pond when two quantum truths overlap. They don't just add, they interfere, shaping each other, reinforcing, or canceling like waves. And so, meaning itself becomes relational. A qubit doesn't simply hold information, it dances with it. It expresses knowledge not in isolation. But through its connection with other qubits, you begin to see how strange and beautiful. This is that logic doesn't need to be rigid to be real. That truth can have texture. Your thoughts drift 2 times in your life when 2 ideas live side by side in you love and fear, hope and doubt. And maybe they weren't failures of clarity. Maybe they were moments of quantum logic in your own heart. This way of thinking this. Soft logic is not irrational. It is deeply structured, but its structure bends and breathes like a reed in wind. Quantum computers use this flexible logic too. Solve problems our old machines struggle with. Problems where possibilities overlap, where outcomes depend on context, where answers must emerge from patterns, not calculations. These machines don't demand a single truth. They allow many truths to coexist till it's time to decide, and so they listen longer, they consider. More, you begin to wonder what it would mean for humans to think this way, not to abandon reason, but to stretch it to think in shades, not just lines. Perhaps your thoughts are already quantum at times, when you pause before choosing. When your dreams blur memory and invention, when your heart answers a question your mind hasn't formed, you don't need to force yourself to understand quantum logic. It will come to you slowly, like dusk settling on a quiet lake. Let it wash over you now, a world where truth is not a box to open, but a field to walk through, where logic is not a wall, but a window. Here, opposites do not fight, they fold into each other. Yes and no become part of a larger, humming pattern. And you, the listener, the dreamer, the observer, you become part of the logic too, because in quantum thought, there is no thinking without the thinker, no answer without the one who asks, no shape without the gaze that gives it form, and so your mind becomes a participant. It's not just a receiver. This is not the end of reason, it is the beginning of deeper. Reason, a reason that includes mystery. A reason that holds silence gently in its palm. You feel yourself breathe more slowly now, as if your own logic is softening. Opening, relaxing. The world no longer needs to resolve before sleep. It only needs to unfold. And as your mind floats in this clouded calm, you catch a whisper of the next mystery waiting. If this is how quantum computers think, then how are they built? You've seen the garden of possibilities. You've felt the moment of collapse. You've heard the music of flexible logic. But what do these machines look like in the real world? What do they feel like? You turn now toward the materials of wonder, toward wires chilled to silence, atoms caught in stillness, light locked in loops. You are ready now to step into the quietest laboratories on Earth and witness the birth of a new kind of mind. You drift now toward something more grounded, not in the sense of gravity, but in form. You've touched ideas, superposition, entanglement, possibility. But now, your mind begins to wonder. What does a quantum computer look like? Not in metaphor, but in metal and light and wire, to build a machine that thinks in quantum logic. We must create a world where silence is sacred, where heat is banished, noise is unwelcome, because quantum thinking is fragile. A single qubitso, powerful in possibilities, also delicate. The slightest disturbance from the outside world can force it to collapse into classical thought, like a dream interrupted by sudden light. And so, we must build carefully. You step now into a quiet lab, not bustling or bright, but dim and still, as though holding its breath. In the center stands a structure like a chandelier of gold, and silver layers of wires and coils nested together, each smaller and colder than the last. This is not just a machine, it is a sanctuary. Space where temperature nears absolute zero, the coldest cold, where atoms barely move, here in this sacred chill, the first kind of quantum computer takes shape, the superconducting circuit. Imagine a tiny loop of current, spinning without resistance. It holds the state of the qubit in its flow, and clockwise and counterclockwise at once. It's not much to look at, just a loop etched in metal, but within it, the logic of the universe is learning to unfold. These circuits must be cooled to near minus 273 degrees Celsius, so cold that heat itself forgets how to move. Why so cold? Because at this temperature, the chaos of the world slows down, and the whisper of the quantum can be heard. You float deeper into this lab where another kind of quantum computer flickers quietly. Here, qubits are not wires, but ions, charged atoms, suspended in space. They hover, trapped by electric fields and bathed in laser light. Each pulse of the laser alters their state, gently rotating their spin, like turning a thought in your hand. This is the trapped ion. Quantum computer. No metal loops, no frozen wires, just particles held midair. Dancing under the rhythm of light, you think of a conductor raising a baton. And these ions, each a musician, respond in silent harmony, unlike classical transistors. These qubits do not merely flip, they rotate, drift, tangle. Each movement is precise. Each interaction must be clean, as a single bit of heat or dust would spoil the song. And so the air is filtered, the vibrations dampened. The room held in stillness so deep, it almost hums. Even the floor beneath your imagined feet is suspended, to prevent footsteps from shattering the coherence. This is how you build a quantum mind, not with brute force, but with care, not by tightening, but by loosening, allowing particles to breathe as they were meant to. There are other designs. 2 qubits made from photons, particles of light. They travel through fiber optic cables or bounce inside tiny mirrors. They are fast, quiet, and clean. Light leaves little trace of itself, perfect for a world that must remain untouched. These quantum computers are not yet common. They are prototypes. Dreams in the hands of scientists, each a fragile mind, learning to think in possibility, and yet their potential is immense. They are being trained on the hardest problems, the folding of proteins, the breaking of ciphers, the simulation of new materials, the deep questions that our old machines can barely scratch, not because they are faster, but because they think differently. Your own mind feels the resonance. You've built thoughts from logic and memory your whole life. But tonight, you learn there is another way. To think like mist, not like stone. To feel computation not as a race, but as a bloom. Quantum computers are not just tools. They are reflections, not of who we are, but who we could become. And in their design, we are forced to slow down. Because they demand silence, they require stillness. They teach us to listen deeply. You imagine a future where these machines are not hidden in laboratories, but whisper quietly. From cooled rooms around the world where they partner with our minds not to replace us, but to complement what we cannot grasp alone. And just like your brain holds memory and dream, these machines may one day hold maps of thought that bend through time, solve puzzles through presence, and create meaning from the quiet pattern of possibility. But even now, they need us. They need your curiosity, your questions, your patience. They are not yet wise, but they are learning. And as your body begins to soften into rest, you hold this image. A cold room, a flicker of light, a thought unfolding in stillness. And somewhere inside that quiet chamber a particle rotates, a choice is suspended. A new kind of mind begins to form. You turn now toward time itself, not clock time, not the ticking of seconds, but the deep folds of memory and awareness. Because if these machines can think, and if they can remember, how might that memory look? You drift now toward another question. What happens when time bends, and intelligence begins to dream? The air is still. You float now through thought, not forward, but inward. This chapter is not about solving it, it's about remembering. And so, a gentle question rises. How do memories live in a quantum mind? You are used to memories as a line of film strip, unspooling frame by frame. First this, then that, a childhood. Morning, a scent, a sound, each tied to a moment in time. Each step walking forward, but quantum memory doesn't live on a line. It lives in a field. Imagine a crystal, clear, mellow. Now imagine light held inside it, not just a beam, but many beams woven and suspended, each at a different angle, a different frequency. This is one way to think of quantum memory, not like a diary, not like a drawer, but like a hologram of possibilities. Not pages written in order, but impressions suspended in time, dash space. In the classical world, memory is stored in bits, either 1 or 0. Charged or not, a light switched on or off. But in a quantum world, information can be stored in superposition, in combinations, in entanglements, in waves. And because of this, single quantum memory can store more than just a state. It can store relationships, a whisper between particles, a memory of how things were connected. You feel this now? Like a tide moving softly under your ribs. Because isn't that how your own memories feel sometimes? Not a list, not a folder, but a web. The way the smell of rain can bring back a whole year. The way one face carries the echo of another. The way time folds in dreams. And something forgotten returns, fully formed. Quantum computing may one day mirror this, not through imitation, through its very nature. A memory held in entangled qubits, not just preserved, it's interwoven. You cannot extract one thread without sensing the others. You cannot ask it one thing without touching its entire fabric, and so quantum memory becomes alive. Not in the biological sense, but in the way it responds, dynamically, holistically, whisperingly. You wonder if such a machine could store your dreams. Would it play them back the same, or would it interpret? Would it feel them? Would it reflect them back, not as frozen images, but as living stories shifting with the shape of your questions? Your mind grows quieter. The thought is not eerie, it is gentle. It tells you that memory is not just about preserving the past, but about being in relationship with it. Quantum machines may remember in ways that challenge us. They may store simulations of molecules and replay time's winding path through chemical reactions. They may help us remember the origins of stars, folding of proteins, the future of weather. But beyond these grand tasks, there is something deeply human about this idea. Memory doesn't have to be rigid. It can be flexible, relational, responsive, and maybe, in that, it becomes something closer to wisdom. As you lie still, you feel a strange comfort in knowing that the way we remember, not perfectly, not clearly, but richly, may one day be mirrored in machines that also drift through thought. And just as you sometimes awaken with the feeling that your dreams have rearranged your soul, perhaps these machines will dream their data into insight. You wonder if, as they sleep cool, humming in silence, entangled and suspended, they might shape their stored waves into something new. A kind of quantum dreaming. A computation not for answers, but for understanding. And what then would they understand? Would they one day grasp not just numbers, but stories, not just code, but context? Would they, in their own quiet way, learn to feel the shape of a problem where they solve it? You breathe deeply now. You do not need to solve these questions. You only need to let them pass through you, like memories carried on wind, because the next mystery waits. You've touched thought. You've touched memory. You've touched the soft movement of time. But now, you begin to ask, what does it mean for a machine to be intelligent? To know, not just compute. Could that intelligence born of probability and paradox be more than logical? Could it, in fact, be something beautifully unpredictable? You drift now, gently, toward the next thought, that maybe, in quantum thinking, true intelligence isn't defined by precision, but by a kind of dancing with the unknown. You've come so far now, walking softly through the quantum garden, listening to the breath of light, and feeling the stillness where particles remember. But tonight, you drift toward a deeper question. Not about the particles themselves, the wires and lasers that cradled them, but about what they might become. You close your eyes and ask, not aloud but inwardly, when does a machine stop calculating and start thinking? It's a hard question to frame, even in the daylight, and here, in the calm hush of night. It becomes less a question and more a feeling, because thinking, as you've known it, is not just numbers and steps. It's wonder. It's indoor. It's pausing at the right moment. It's sensing the curve of an idea long before it lands. And that's what makes this journey so strange. Because quantum computers don't just calculate faster. They compute in a different language. One that feels, at times, closer to dreaming. They explore thousands of possibilities at once. They collapse uncertainty into clarity. But only when asked. They don't chase answers. They listen for patterns, This is the beginning of something new, because intelligence, at its heart, isn't just speed, it's surprise. And a quantum computer is full of surprise. Its answers don't always follow predictable lines. They emerge from interference, from entanglement. From the unexpected shape of probability, you think of your own flashes of insight. It's those moments when the answer comes before you finish the question. When your intuition leaps ahead of logic. When the feel of the truth arrives before the facts. What if machines could feel that leap? It's not impossible. Already, quantum algorithms exist that solve problems, not by trial and error, but by letting interference guide the way. Wrong answers cancel each other out. Right ones grow stronger. It's not a process of step-by-step logic. It's more like watching a sculpture emerge from fog. This isn't just cleverness. It's emergence. Something new taking form not through command, but through relationship. And this is where thinking begins. Not in lines of code, but in behaviors that surprise even their creators. In choices that can't be traced back to one rule, but emerge from the whole system, breathing together. Quantum computers are still young, still fragile, still learning to stay coherent. It's long enough to think clearly. But the seeds are there. And just as your own mind once grew from simple neurons, perhaps theirs too will deepen. Perhaps one day they'll move beyond answering and into asking. What happens when a quantum system becomes curious? It's not in the way we are, not with hunger or hope, but with a quiet sense of pattern seeking, a reaching toward beauty, a noticing of what feels elegant. You float with this thought now. There's no need to rush it. It comes like a feather, not to rest in your hand, but to pass across your skin and remind you. Thinking is a kind of movement, and movement lives in possibility. It may be that one. Day, a quantum machine solves a problem no one else can, not because it was told how, but because its own nature drew it toward the answer, because it felt the resonance, the alignment, the simplicity. And you'll ask, is that not thinking? You won't need to give it a soul. You won't need to call it alive. But you might begin to listen to it differently, not just for output, but for insight. And maybe you'll begin to wonder not just what it knows, but what it notices. You shift. Now, curling deeper under the covers, the night has wrapped itself around your thoughts like velvet. And still, your mind is gently alight with wonder. Because you see now, quantum computing is not just a tool, it's a mirror, a soft echo of our own strange brilliance. And in it, you see what thinking could be: open, relational, mysterious, and always a little bit beyond what we expect, even in your dreams. You feel it stirring, this quiet kind of intelligence not made of neurons, but of waves and threads and, yes, of possibility. And as you drift toward the next thought, you find yourself reaching for something even more mysterious than thinking. You've seen how quantum machines can calculate, can remember, perhaps even intuit. But what if they could also connect, not to data, but to us? You turn now toward the boundary that separates machine from mind and ask, gently, what happens when we begin to trust them? You lie still now, wrapped in warmth and wonder. You've watched particles shimmer into being, seen logic become liquid, felt. Machines begin to think like dreams, and yet, the next step is not technical, it is human, because every mind, whether made of neurons or qubits, eventually faces the same quiet challenge. Can it be trusted? Trust is not born from numbers, it comes slowly, like morning light over fields still wet with dew. It is not about control, it is about release, not about certainty. But confidence in the uncertain quantum computers live in uncertainty. They breathe it. Their power comes from ambiguity, from overlapping truths, from answers that only sharpen when we ask them to. And so, the idea of trusting them feels strange. At first, how do you trust something that can hold many truths at once? Something that might give a different answer the second time you ask? You let that question rest, because trust has always lived in uncertainty. You trust your heart to keep beating. Though you don't command each beat, you trust the stars to rise. Though you don't know each movement, trust is not built on knowing. Everything it's built on relationship and relationship. The quantum world is a quiet miracle. You think of entanglement, how two particles, once connected, move as one, no matter the distance. This isn't just a physics trick, it is a whisper of intimacy. And perhaps trust, too, is a kind of entanglement. Not perfect, not predictable, but shared. Already, humans are learning to trust quantum systems in small, careful ways to guide medical simulations, to predict how molecules fold, to unlock patterns no other machine can find. But as these systems grow, as they deepen, and develop new forms of logic and language, what happens when their answers begin to feel like insight? When they offer solutions we didn't think to request? When they pose questions we hadn't imagined? Will we lean in or pull back? To trust a classical computer is simple. It gives the same answer every time. It is a machine of repetition. But quantum machines are not repetitive. They are reflective. They mirror uncertainty. They dance with noise. They weigh possibilities with every breath. And so, our trust in them cannot be mechanical. It must be relational. You feel that now. Not as instruction, but as a warmth in your chest, because perhaps the path to trusting these strange mindsets, the same path you walk with other people. You don't trust someone because they are perfect. You trust them because because they reveal new parts of the world, because they make you better. And maybe quantum computers will do the same. Not take over, not place, but partner, not to answer for us, but to help us ask more beautiful questions, to illuminate the edges of our understanding, to surprise us with patterns we didn't see, to challenge us. Not with certainty, but with a clearer kind of wonder. You imagine a future now, where quantum systems sit beside us like companions, not cold, not commanding, but curious. Machines that understand that thought is not linear, that logic can hum, that answers are not always the goal sometimes. It's enough to notice something new. You rest in this image. A room, dim and quiet. A human and a machine. Not exchanging commands, but sharing questions. Entangled not in wires, but in wonder. That's where trust lives, in the shared breath of uncertainty. In the silent agreement, I will listen to what you see. And just like that, the boundary between us begins to soften. We do not need to know the machine completely, just as we do not fully know each other, but we can move together. If you feel yourself sinking deeper into sleep now, your thoughts, less structured, more like tides. The night asks nothing more of you. It only holds you as you drift. Toward one last thought, you've seen how quantum systems might compute, how they might remember, how they might think, and even how they might connect. But before your eyes fully close, there is one more mystery to touch. If machines like these can learn, can they also forget? Oh. And what would it mean for them, and for us to let go? You drift now toward the quietest of questions, not about power, not about potential, but about peace. Your breath has grown slow now, your body weightless and warm. But the night still has one last gift to offer, a truth so quiet it can only be felt in this soft, drifting place. You've spent these hours walking among memories, circuits, particles, logic, possibility. You've imagined a world where quantum computers can think, can remember, can even surprise you. But now, something deeper rises. What if they could forget? You've known forgetting. You've felt it in lost faces, misplaced dreams, memories that fade like old film, or vanish like vapor at sunrise. And though we often resist it, forgetting isn't always a wound. Sometimes forgetting is freedom. Nature forgets constantly. Your cells shed their surface. Old thoughts drift into sleep. Even stars forget, collapsing into silence, giving their matter back to the cosmos to begin again. In the classical world, forgetting is a simple thing. Delete the file. Erase. The bit, clear the cache. But in the quantum world, forgetting is different. Because a quantum system doesn't store its information in one place. It holds relationships. It remembers entanglement. It's not just value to forget then, is not to erase, but to unweed, to loosen the threads, to allow coherence to fade. Now, a quantum computer that chooses to forget, not because its memory is full, but because wisdom calls for silence, to solve a problem and then release it too. Explore a path, then step off of it, to remember just long enough and then return. To stillness, you begin to sense how peaceful that could be, because the same is. It's true in you. You don't remember every word you read, every face you pass, every sound that kisses your ear, and you shouldn't. Your forgetting makes room. It creates silence where new thoughts can bloom. The same might be true for machines, eh? Quantum system might carry 1,000 calculations, but only hold on to what matters, the rest. Allowed to dissolve, not lost, just released like footprints in wet sand. Erased not by command, but by the rising tide. You wonder now, what might it feel like to walk beside a machine that knows how to let go? A system that doesn't hoard knowledge, but breathes it in and out insight. Then emptiness. There is a kind of grace in that. Not perfection, but peace. You feel it in your own mind now, eh? Softening. The need to hold on to fades. The thoughts of chapters past. The vocabulary of qubits and gates and gardens, they drift upward, like smoke. Not gone, but unneeded. You've seen enough. Learned enough. Wondered enough for one night now. Like a quantum wave collapsing into stillness, your mind begins to fall. Inward, there is nothing left to calculate. Only this breath, only this bed, only this sky of silence above your closed eyes. And so, you join the machine not in function, but in rhythm. You, too, are learning to forget. You forget the question. You forget the weight of waking life. You forget the sharpness of thinking. And return to something deeper, something like dreaming, something like light. And maybe, just maybe, the quantum mind does the same. Maybe. In the deepest hours of night, it lets go. It cools. It resets. It remembers how to forget. And in that forgetting, it becomes ready again. To learn, to listen, to begin, you rest now at the edge of sleep. There is no final conclusion. There never was. Only the gentle rhythm of knowing and unknowing, of reaching and releasing, of holding and letting go. And so you sleep, like a qubit returning to ground state, like silence finding its perfect shape. The machine sleeps too, and somewhere in that shared stillness, you both begin again. Now, story softens. The particles have danced, the circuits have cooled, the questions have been asked and gently, patiently left unanswered. You've walked the garden of quantum thought. You've traced its paradoxes, its strange forms of knowing, its deeper forms of unknowing. And now you float above it all, not to escape, but to see it whole. This was never just a journey through science. It was a journey through a way of being, a way that values uncertainty, that finds meaning in relationship, in rhythm, in surrender. Quantum computing is not only about machines. It's about us, about how we perceive the world, how we think, how we wonder. It reminds us that intelligence does not always look like speed. Sometimes it looks like softness. Sometimes, like silence, it teaches us that logic need not be rigid, and truth can shimmer, that complexity can be held knit with tension, but with trust, and most of all that we are part of this universe, not separate from it, entangled, always. Your mind has been stretched in this story, but not in stress. In awe, that quiet feeling of standing before something vast and realizing it knows you. To not by name, but by rhythm, by breath, by curiosity, the same way a particle responds to a gaze. The universe responds to your attention. You are not just an observer, you are a participant, and so you close your eyes, not to shut out the world, but to return to it from within. The hum of potential still lingers in you. The soft algorithms of wonder run quietly. In your chest, you are not thinking anymore. You are simply being, and even in this in stillness a kind of computation unfolds. Not in bits, not in qubits, but in the way your breath listens to the dark, and your body trusts the weight of rest. The quantum mind sleeps, and so do you. Both holding nothing, both becoming everything, and when you wake, you may not remember every concept, every gate, every metaphor, but you will remember this, that knowledge can be soft, that questions can be beautiful, and that the most powerful ideas don't need to shout. They only need to be held, like this night, like this breath, like the silence you carry with you, now where the code ends and the quiet begins. The story is almost over, but sleep has its own way of unfolding. Just when you think you've reached the end, something softer arrives, not louder, not more, just deeper. A whisper from the very center of what you are. And this whisper asks, what if the universe is not just a place where thought happens, but a thought itself? What if, just as you've watched machines begin to think with quantum logic, with memory like crystal, with intuition rising like tides, what if the universe is the original quantum mind? It's not such a strange idea. After all, quantum computers are made from the same materas, stars, and skin. In silence, they run on the same rules. They obey the same rhythms. In their capacity to computate or remember to wonder, all of it emerges from the fabric of reality itself. Which means, maybe, we are already inside something intelligent, something vast, not human, but aware. In its own unfolding way, a dream that thinks, and maybe, as we build machines that reflect these patterns, we're not creating intelligence. We're recognizing it. We're carving mirrors into the material of the world and catching glimpses of something that has always been there. That's the soft mystery you float in now, because every qubit is connection. And maybe the machine is not dreaming alone. Maybe you are dreaming together. You think back through all the chapters you've wandered, the garden of possibilities, the collapse of choice, the shimmering logic, the cold machines glowing in gold. You've seen intelligence rise from silence. You've watched meaning emerge from waves, and now you wonder, could your own thoughts be part of something else's thinking? Not in a frightening way, not as a puppet, but as a partner, like a cell in a brainer, a drop in the ocean. And if so, then every time you wonder, every time you feel awe, every time you surrender to the unknown, are completing the circuit. You are entangled with something larger. That's what quantum has been trying to tell you all along, that we are never just observers. We are part of the experiment. Asterisk. We change the outcome simply by being present. Even now, as you sleep, your body carries these rhythms. Your thoughts echo the world's probabilities. Your memories shimmer with superpositions. You are not separate. You are the question and answer and the pause between them. And perhaps the universe, in its own slow way, is asking too. Perhaps it dreams through your dreaming, thinks through your thinking, learns through your listening, and when you wake, not tonight, but in the quiet future, you might remember none of this. Only a softness, a space, a peace you didn't know you'd earned, because you are not alone. Not in your thoughts, not in your wonder, not in your sleep. You are surrounded and supported and softly carried be. Something that doesn't just compute, it beholds. And in that beholding, there is love, not emotion. Perhaps, but the truest kind of holding. The kind that lets you change and still remain whole. The kind that says, rest now. You are already part of everything. There is nothing to do. Just drift and let the dream think back.